bacteria from thin-walled bacteria. The thin-walled bacteria are gram-negative. The major component is still peptidoglycan, however. But what makes this a thin wall is 1 to 2 layers of peptidoglycan. If you have 1 to 2 layers of peptidoglycan, that's not very thick. And if it's not very thick, you're going to need some extra protection. So gram-negative bacteria also have another layer called the outer membrane. Something's coming to my memory. I can't think what it is. Okay, so this thin wall is also what we call heterogeneous. It's made up of 2 different types of components. The first component is 1 to 2 layers of peptidoglycan, and then an outer membrane over that. We'll look at pictures later, but there's good pictures in your textbook chapter 4. Okay, the outer membrane is made up of lipids, phospholipids, lipoproteins, lipopolysaccharides, lipid. This is an endotoxin. And the actual lipid that is the toxic part, they call it lipid A. You'll see that term on your test, lipid A. If I'm remembering correctly. Crystal's giggling about something. What? Did you read that in your book already? He's like, I'm not answering any questions. Okay. Oh, and then there's a whole discussion about endotoxins and exotoxins. We should go into. I'm looking for my other little book. Got so much stuff all over the place. Okay. Let's see if I can find that. Okay, the reason why I'm looking is because remember, how many times have I said I hate the way your book is organized? Yeah, right, because I would bring this up like now, but they don't bring it up till later. That lipid A is an important lipopolysaccharide. It can cause shock, blood clotting, fever. When you take an antibiotic, what do? You kill the bacteria when they go to divide, right? And some antibiotics will just kill the bacteria even when they're not dividing, right? And the endotoxin is released when the cells die because it's part of their cell wall. So if I have a bacterial population in my body that's gram-negative, and I start killing them with an antibiotic, I'm actually going to feel worse. Because as I kill these gram-negative bacteria, they're going to explode and disintegrate. And when they start to disintegrate because they're dying, that's when these lipidy substances are released. And if I give my patient a strong dose of antibiotic that kills off their bacteria too fast, and they release this lipid A endotoxin too fast, I can actually put my patient into a toxic shock. I can kill my patient by giving them the antibiotic too much too fast. So you have to be careful with that. So and the lipid A is actually one of these, an important lipopolysaccharide. Remember that endotoxins are lipidy substances, and lipids are not recognized by your immune system. Endotoxins are lipid toxins. They're not recognized by immune system. In other words, there's no antigens. Well, tell it to God. I didn't invent the human being. See, I told you, I have absolutely no problem believing in God and being a scientist all at the same time. So one's a good excuse for the other. Whenever you can't explain something, God made it that way. That's my answer. You know, where did syphilis come from originally? I don't know, ask God. I believe when you die, all those questions are answered. And if you don't get the answers, death is not the time when you learn, what do you care? You're dead. I choose to believe, however, that when you die, all the answers are there. You have infinite knowledge of everything. So this is hell. All right. So, endotoxins are going to elicit a non-specific immune response. Inflammation, fever. There's a handout, a page in your handouts package about. There's a handout in your package about endotoxins versus exotoxins. Inflammation, fever, that kind of stuff. But too much too soon with this toxin, remember, can throw your patient into shock and can cause their blood to clot up. Right? So we'll just put those down here in parentheses. And they talk about it in your textbook. Now, I've had my textbook for a whole semester already, so I've had more time to read it and remember it than you have. But it's in your book somewhere. Okay. Gram-negative cell wall is a thin wall because it only has 1 to 2 layers of peptidoglycan. But it's also considered a heterogeneous wall because it has another type of a component. That's called the outer membrane. The outer membrane is not the capsule, is not the glycocalyx or the slime layer. It's a different thing. It's part of the cell wall. These two together make up the gram-negative cell wall. And when gram-negative bacteria are killed, that's when their endotoxins are released. So, gram-negative bacteria also, when we do a gram stain tomorrow in lab, you'll see gram-negative bacteria come out red from the counter stain. So gram-negative are red from the counter stain. And gram-negative bacteria make endotoxins. Negative, right? Endotoxins. And endotoxins are released when the cells die.
Have we figured out how to, I don't know, get rid of this lipid somehow?
What?
Is there any way to kill that outer membrane somehow? With the toxin of the
Well, you gotta kill, if you kill the outer membrane, you're gonna kill the whole bacterium.
Yeah, but is there any way to kill the gram-negative?
Yeah, why do you think your body's spiking a fever and inflammation? It's trying to kill it. Your body spikes a fever because it's trying to break down the toxin. Trying to denature the toxin somehow. Trying to break it down. You can't denature a fat, but.
So there's no way to use a drug that could kill the endotoxin?
Right.
There's no drug.
Nope. But exotoxin is different if we get a vaccine, so we'll do that next. Okay, that's gram-negative bacteria. Now we're going to do gram-positive bacteria. And then don't let me forget about acid fast. Okay, gram-positive bacteria. These are thick-walled, and they're homogeneous. The thick-walled bacteria, it's thick because it's 6 to 8 layers of peptidoglycan. But that's all it is. It's homogeneous. If you look at the picture in your textbook, you'll see they show you molecules of teichoic acids throughout the gram-positive wall. So it does have some lipids in it. Embedded in it. But what makes the gram stain come out is not related to the teichoic acids. You will see a question in your test about that, but I don't usually focus on that. All right, you've got 6 to 8 layers of peptidoglycan, and that's all it is. What does a cell wall do? It gives the bacterium shape. So think about your Spanx or your shapewear. It's made of lycra spandex, right? It's made of elastic. So when you put that on, it gives you a shape, right? So the cell wall is what gives the bacterium a shape. If it's rod-shaped, it's because of the wall. If it's round, coccus-shaped, it's because of the wall. The wall is what gives the bacterium shape, and it does afford protection to the bacterium. These are endotoxins, but all this lipidy stuff, this is also going to resist